Section 4.1, Inverse Functions, Part 3. In this part of the notes, we're going to focus on equations of inverses. So in the last part of the notes, we found inverses by interchanging x and y values of ordered pairs. We're going to do the same idea here when we are finding equations of inverses. So we're going to switch x and y and then solve for y. Here's our steps written out. For a one-to-one function, f, defined by an equation, we find the defining equation of the inverse as follows. First of all, we're going to interchange our x and our y. If your function doesn't have y, if it has an f of x instead, then just remember that f of x and y are the same thing. Step 2, we're going to solve for y. And then step 3, we're going to make sure that in the end, we replace y with f inverse of x. Example 5, determine whether the equation defines a one-to-one function. If so, find the equation of the inverse. So for part A here, I have a linear function, and I need to decide if it's one-to-one. Since linear functions, this is a non-horizontal linear function, but since linear functions always increase or decrease, they're definitely going to pass our horizontal line test. So f is a one-to-one function. In the next part, we're going to find our inverse function. I've put those 3 steps down here in case you need to look back at them. So first of all, instead of putting an f of x equals 2x plus 5, I'm going to start with y equals 2x plus 5. And then I'm going to interchange my x and y. Notice the 2 didn't move with the x. I'm just flipping the letter x and the letter y. Now I'm going to solve for y. We start by subtracting 5 to the left side and then dividing everything by 2. I'm okay if you leave your answer like this. The other way that we can write it is 1/2 x minus 5/2. So 1x becomes 1/2 x and negative 5 over 2 becomes negative 5/2. You definitely, however, need to put the f inverse of x at the front of the equation. Example 5, part B. We are going to determine if y equals x squared plus 2 is a one-to-one function, and if it is, we'll find the inverse. So the graph of this is a parabola. It's been moved up to, and we need to stop and think about whether this passes the horizontal line test. It actually does not pass the horizontal line test because a parabola, remember, it's a U shape. So we could have a horizontal line going through it and crossing it twice. So since it's not one-to-one, I'm not finding the inverse function. Example 5, part C. We have f of x equals x minus 2 quantity cubed. So first we need to decide if this is a one-to-one function. Remember, cubic functions, think about what that graph looks like and whether it passes the horizontal line test or not. Hopefully you said yes. All cubic functions are going to pass our horizontal line test because they are always either increasing or decreasing. Next, we're going to find the inverse function. So start by, instead of putting f of x, put y. Then we're going to switch our x and our y and solve for y. So since I'm trying to get y alone, looking on the right side, the first thing that I need to get rid of is the cubed. The inverse operation of cubing is cube rooting, so I'm going to cube root both sides. And then I'll add over the 2. In the end, we need to rewrite it as f inverse of x equals cube root of x plus 2. Example 6, we are going to find the inverse of a rational function. So the rational function f of x equals this for x not equaling 4 is a one-to-one function. So in this problem, they have already told us it's one-to-one. We don't have to worry about figuring that out. We're going to find the inverse. Really quick, let's talk about the x cannot equal 4 part. We just have that in here because if x equaled 4, we would have 0 in our denominator of our rational function, which we can't have. So it's just kind of tagging along and reminding us that x can't be 4. The first thing we're going to do is instead of putting f of x, we're going to put y, and then we're going to switch all of our x and y values. Next thing I need to do is, since I have a fraction, I want to get rid of that, so I'm going to multiply the denominator of y minus 4 over to the left side. So now that I've gotten rid of my fraction, I'm going to distribute the x to the y minus 4. Now at this point it might look a little confusing, but here's our goal. We want to get all of our y terms on one side and all of the terms that don't have a y on the other side. Because remember, we're trying to solve for y. So I'm going to subtract 2y over to the left side, and I'm going to add 4x over to the right side. So I get xy minus 2y, because I subtract it to the left, and positive 4x plus 3. Okay, my next step, I'm going to undistribute. I'm going to pull out a y from the xy minus 2y. So I'm undistributing that, pulling out a greatest common factor here. Now, instead of having 2 y's written in my problem, I just have 1 y. My last step, I need to get rid of the x minus 2, so I'm going to divide that over. And then replace y with f inverse of x. To graph inverse functions, we're going to start by finding some ordered pairs that are on the graph of f. We're going to take those ordered pairs, we're going to interchange our x's and y's, and then we're going to plot those points and sketch the inverse of f. Here's a little of what we should expect whenever we graph inverses. So in this left example, I have linear functions. F is my blue equation, or my blue line. The inverse of f is reflected across the line y equals x. So we can kind of see that once we interchange those x and y's in the points, they're going to reflect across that line. On the right side, my blue function is half of a parabola. And whenever I find the inverse, if I reflect it across y equals x, I'm going to end up with something that looks like a square root function. Example 8, we're going to find our inverse function of f, and we're going to graph both of these functions on the graph. So first of all, let's start by graphing function f. It's a linear function, y equals mx plus b. So I know that I can graph this by starting at 3 on the y-intercept and then doing my slope, up 2 over 1, or I can go backwards, down 2, backwards 1. Now that I have those 3 points, I'm going to draw a table and put those 3 points in it. To get the inverse of f, I'm just going to take that table, I'm going to rewrite it and flip all of my x's and y's, and then plot those points and graph f inverse. So I'm going to flip all of those points in green, plot these 3 new points, and then notice it looks like my graph, the green graph, is reflected across the line y equals x to become the red graph. Example 8.5, function f is graphed in red. We are going to graph the inverse of f. So what we're going to do here is we're going to look closely, and you can see 4 points along the function f. So we're going to put those in a table. And then to get points for the inverse of f, we're just going to flip each of our x and y's and then graph those points. Notice that the points have all reflected across the line y equals x that I've drawn here in orange.